Okay, welcome everyone. Sorry, I'm just testing my pen.
Welcome, Limka. How are you today?
Let's see who's in the... There we go. Yeah, there's Lumka. I find my brain switching between the various classes. I was like, when I first went on today, I thought, am I graded 8 or grade 11?
I don't think the grade 11s will enjoy us, or maybe they will enjoy us giving them a grade 8 class rather.
Yeah. I think it's because when you're in the physical classroom, you obviously have the trigger of seeing people's faces or the room that you go to. Whereas for us, it feels very much like it's quite similar when you sit down, and it only becomes different when you see the names or when you hear the voices.
Of course.
Lumke, how does it feel compared to a normal classroom for you? We were just discussing how it definitely feels different as a teacher, although every day I do this, it feels a bit more normal.
Hi, Solo Fellow. Welcome.
Welcome to Velo.
What do you guys prefer? Do you prefer online tutoring or in-class maths?
Good question. Good question. I'm curious, as a maths teacher, like what feels good about this way and what feels, I suppose, different or worse?
So, fellow Lumka, if you have any answers, let us know.
Oh, interesting. So less distractions. Yeah, I suppose if you are able to focus yourself, it's yeah. Classrooms can get a bit rowdy at times.
That's awesome.
What does everybody else think? Like pros and cons, what's different about, what feels different about this space? I know I'm becoming more and more aware of the things that like are actually really easy to do in this space. And then the other thing for me is just to get a sense of my students is actually quite hard in this space. So you have to really work to get to know the students, probably harder than you do in the physical classroom. Or it takes a bit more time. I think that definitely stands out for me.
So the fellow prefers in class.
Totally.
Welcome to Senesipo and Valerie.
So while we're waiting for everyone to arrive, if I could just, today's lesson is really going to focus on groups of data. So how do we move from individual data items to groups of data? And so there are 3 questions up. And while we're just welcoming everybody, question 1, question 2, and question 3, and they're all multiple choice, which is so lovely for participation. So we'll call this A, B, C, and D, A, B, C, and D. And if you could just get going with that, and then we'll have a little vote, just to warm you up for the day. People at home or watching on the website, you can play along too. I'm told there's a voting thing. Ozan, can you see those votes coming in?
I'll get the votes now. Quickly see where I can find it.
Yeah, I'm not sure if you can. I think I heard somewhere that you can see that.
Yes, we normally had a link. I just need to go and find the link, then we're good to go.
So just while everyone's getting going with this, I just want to highlight some of the do now questions. This one is about the mean, but the problem is finding the mean when the data is grouped into, well, when it's basically counted per, actually, no, this is just individual items, so that's not too bad. But the second one is in thing, and then the third one, oh yeah, this is in groups over here. So let's just look for the keywords. How many more runners? So that's that question. And how many children are in the group? So let's see those answers coming in. What do you guys think? I see one answer has been locked in for question 1. Would you like to give us a hint about how you did that? What was a key step or a key idea that you used? I haven't actually worked out the answers for these ones yet, so I'm going to be as surprised as you are when we find out. We'll do this now. So when we think about the mean, we need to know on the bottom how many items there are. So an important value will be 3 plus 5 plus 5, it's 13, 14, 15. So that's one value we're going to need to know. And I'll give you a hint for this one. We're also going to need to know the cumulative frequency of this group. So 4 plus 3 and so on. So that's useful. So let's see a few more answers coming in. I'd love to see, because today's lesson will build from here and then we'll go. All right, Ozan, I'm going to get started properly. Are you anything more from you before I get going? I think you're on mute, maybe. Are you on mute?
Oh, sorry. I thought you guys can lip read. No, I was just saying, well done, guys. You're halfway through. Enjoy today's lesson, and then I'll see you again afterwards. And Peter, I'll keep you updated on the live classes.
Perfect. Thanks. Okay, everyone. So like I said, group data is the main focus today. And so just in these first questions, in order to get the mean, the thing I need to do here is there are actually 3 35,500s. There are 5 42,700s. And so we actually need to total all those up. And so what we're going to do is I'm going to take my calculator and I'm just going to go 35,500 times 3 plus 42,750 times 5 plus 51,000 times 5 plus 99,000 plus 150,000. As long as I've done my calculations correctly, or I'm sorry, my adding up correctly, I get a total of 82,4250. And then I'm going to divide that 82,4250 divided by 15. And I get 54,950. So question 1's answer is B. And so just to point out that when we say frequency, it means that basically this thing happened 3 times. That's why in my calculation, I was going 35,500 times 3. Okay. The second question, now this is actually something called a histogram, which we're going to talk about today and was part of your homework. And basically what it's got is it's got frequency or the number of items on the vertical, and then it's got these intervals on the horizontal. And the question says, how many more runners ran 5 to 6 miles than ran 7 to 8 miles? So first I need to know the frequency of each group. And it looks to me like there are 5 people in that group and there's 1 person in 7 to 8. And so the difference is 5 minus 1, which is 4. And so the answer for number 2 is going to be 2A. Okay. Then for number 3, it says the table shows the frequency of the number of visits to the doctor per year for a group of children. So there's a big group of children, and some children are not going to go to the doctor at all. So that would be this column over here. Maybe you're just really healthy, or maybe you only went once in the year. And so there's 3 people or 3 children who went once in the year. I often find students, when they see these tables, it takes a while, and for me too, I have to slow down and just get a sense, what is this actually saying? This column over here says there are 8 students or 8 people who went to the doctor twice in the year. So take some time to figure that out. Now, the question, how many children are in the group? Well, this is simply the cumulative frequency, or counting the frequency of all the groups. So that would be 7, 15, 20, 25. And so my answer is going to be 3C. Okay, give me a thumbs up or thumbs down to show me how you're feeling about that. Like, was that encouraging? Do you feel like, oh, you need more of that? Just a quick little feedback for the teacher at the computer. Because today we're going to build on this idea of group data over and over again. Okay, I see that thumbs up. Thank you very much. What do you think, Jessica? Marilyn, how are you feeling? Give us a thumbs up or thumbs down. So say it to up. There we go. Okay, let's rock and roll. So I'm trying to get the right structure for these lessons. And so I just want to take a moment to just quickly review what we've done recently. And in the first lesson, we did calculations. And we spoke about things like the mean, the mode, and the median. And we spoke about the range and the standard deviation. So basically, where is the middle of the data and how spread out the data is. And if you've missed those lessons, you can go back. Okay. Now, thanks, Ozan, I see that. If you wanted to know how, okay, so those are the calculations. Then we moved on to how do you graphically represent the data that is summarized with our statistics. And we looked at something called a box and whisker plot. And back here, we spoke about things like quartiles, Q1, Q2, and Q3, which tells us about how ranges in the data. So basically, the data can actually be almost divided up like in a fence. And if you imagine the data being plotted along a number line, then we have these sort of markers, and the value of Q1 is basically just 25% of the way through the data. Q2 is halfway through the data, Q3 is 3/4. And, this idea of, okay, where is the middle 50% of the data? Well, that's going to be between Q1 and Q3, and we call that the interquartile range. And we did a whole bunch of sort of stuff about that. And then we did this thing about basically the 5-number summary, and the 5-number summary is basically what's on the board plus the minimum and the maximum value. And we put this into something called a box and whisker plot, where it shows us the 5-number summary spread out over a graph. Then we were still dealing with individual data items. We had long lists, and you had to deal with the items. Now, today, we're focusing more and more on how do we group data into intervals. So like an interval might be from like 0 to 10%, from 11 to 20. And then we have a frequency column, which says, okay, how many people were in that group? Maybe there's 2 people in that group and so on. And then we'll even have what's called a cumulative frequency, which counts up how many people in total are up to that point. So in this case, we would say there's 5 students who are scoring, let's say, below, or let's say there's 5 students who are scoring below 20% in this group. Okay, so that's just my little review. The preview is that we're going to learn all about how do we do charts or graphs for grouped data. So that's where we're going. We will learn about something called a histogram. So that's the one type of graph we're going to learn about. You're going to learn about, you're also going to learn about how to describe the shape of a histogram, or the shape of what we call a distribution. And a distribution in statistics is basically the graph that's made from groups of data. And then we will also do something, I don't know if we'll get to it today, but something called a frequency polygon. And actually, and this will be the next lesson, there's one more chart called an ogive, or sometimes it's called a cumulative frequency chart. So you can kind of see why I've been sneaking in the word cumulative frequency, because it's going to come up later. So as we move forward, I think it's good to have this scaffold in your brain, because we'll be, kind of doing this type of thing. Okay, let's move to the first type of chart for today. So this is a typical question, and we're going to do this together so that we kind of understand what it means to draw a histogram. So that's the goal. Now, very rarely in an exam, okay, let me back up for a second. This set of data is a mess. It's so much detail that I don't really know what's going on. It says here that these are the results of grade 11 students, maybe for a test or an exam or something. As a teacher, if I want to get a sense of what's going on here, this is not very helpful. And so what we're going to do is, in one sense, we're going to group the data into groups, and then we're going to count the frequency in each group, and then we're going to make a graph of that called a histogram. And a histogram is a lot like a bar graph, except that it shows there's no gaps. It's not categories, but rather it's ranges. And so we're going to go through that process. If we look at the little bit of theory notes, it's maybe worth highlighting a few points. It gives us a visual interpretation of the data. And I often look at histograms as a teacher. It's part of my job. The main difference between histograms and bar graphs is, like, bar graphs tend to have like categories. So you might say, like, what's your favorite TV show? And you would say, like, 7 people say The Big Bang Theory, 5 people say, whatever other, and you have separate categories with gaps. Whereas histograms tend to be about values where there's no real boundary. We artificially choose the boundary. And so a lot of the time we choose 10, but it doesn't have to be. So this is a very common exam question. Normally in the exam, what they do is they don't ask you to actually put it into categories, because it would just take too long. So they often give you the actual frequency table. And so I'm going to try and put this on the screen so you can see what's going on without getting confused myself. If you just give me a moment. Okay. Come on, behave yourself. OneNote. I think like everyone is. Okay. Give me a thumbs up if you can see the frequency chart. I don't think I'm going to get it better than that. Thumbs up if you can see the frequency charts. It's this part of the screen that I'm talking about. And then up here, I have my questions. Okay, can everyone see okay. So, like I said, this thing over here, what a mission to try and make sense of what's going on. The good news is they have put categories over here. And what this is saying with the crocodile mouth is T could be 10, it could be 11, 12, all the way up to 19, but it couldn't be 20. And then the next category, it's going to start at 20 and go up to 29. And so those are the intervals. Sometimes they call them bins. And then in each interval, there's 2 students in that category. There's 4 in that. And if you go through and check this data, you'll see that that makes sense. And the total of that frequency column is 50, which means there's 50 students in the group. Okay. Now, if we're going to draw a histogram of this data, what we need to do is we're obviously going to have a bar chart. Now, or not a bar chart, sorry, a set of axes. And on the vertical axis, we will have frequency, or we'll have, in this case, you may even say number. This looks like Halloween writing. Number of students. So you'll have like categories going like that. And this, might go up in a certain amount. And then over here, we're going to have our intervals. And so the first interval is from 10 to 20. So we may say from 10 to 20. Just going to zoom in. And so you can see where I'm going with this. And so once you get, for example, I'll do the first one. If that's 2, I'm going to have a bar that goes like that. And for my second category, which is 20 to 30, it's in line with 4. And so assuming that's 4, I know this is messy. I'm just going to give you an idea. Then I'll put the neat one up. We get another bar. And so what this does is it tells us, it gives us a shape of the performance of this class. Okay, so now what I'm going to do is I'm going to show you what the sort of neater version looks like, but I just wanted to give you a feel for how you would put it together. So this is kind of the perfect way of doing it. Put that there. That's how you would do it the perfect way. And then the actual graph itself will look like this. Excuse me while I just quickly get let me copy and paste. There. Okay, wow. Let's get rid of this for a second. Okay, I clearly need to practice in OneNote a bit more. Anyway, this is the histogram. It tells me a story. And so in statistics or data, we often talk about the shape of the graph because the shape tells us about the performance of the students. So if we go back to the actual questions, I've showed you how to draw a histogram and how to organize the data. Which of the intervals do you think is the modal interval? So the modal interval, and I'm going to give you choices. Is it going to be A, B, C, D, E, F, G, or H? Which of these intervals or groups is the modal interval, knowing what you know about the mode? I'd like some answers from my class, please. So Markle has locked in her vote. I feel like I'm running one of those game shows, you know, like lock in your vote and there should be awesome music in the background. Oretiwe, I see the votes coming in. Sasetu, thank you very much. You are quite right. Valerie, I see your vote. Fantastic. Marilyn, I see your vote. Jessica, everybody's on the same page. You are all correct. The mode is the group. The modal group is the one that occurs the most. In this case, it's 11. Okay, fantastic. Now, let's see. Estimate the median. Okay, the median is a little bit harder. Not impossible, but a little bit harder because the median is in the middle. But now, when you don't have individual items, I suppose we do have individual items. They're hiding in this mess up here. We're going to estimate where the median is, basically using estimation. So when you do that, you need to know how many items are there. And if you remember the table we did, there were 50 items in total. Now, if we use from earlier lessons, if we want to find the position of the median, we are going to find its position by using this formula. Must be zoomed in. Position of the median, and I call this Q2, is just a half times n plus 1, which means it's in 25.5's position. Now, that's not the value. Again, I say this a lot, but I've really got to be clear on this. This is not the value of Q2. It's the position. The value of Q2, or the estimated median, is going to be hiding in a category here. So, and this is where a cumulative frequency table is helpful because we know there was 2 people in that category, 4 in that category, 4 in that. There are 7 in that category. There are 11 in this category. Now let's count. It's 6, 10, 17, 28. So I think that my median must be hiding in this category. And if it's in that category, what's a good way to estimate something if it's in a particular range? What we always seem to do is just find the middle. So what is my estimated median going to be? I'd love for you to type in what you think it is in the chat. What's the estimated median going to be, or the Q2 value? How do we know what value? We know it's in this interval because we counted and we know where position 25.5 is. It's like that's going to be 6 in total, or cumulative frequency. That's up to 10. up to 17, up to 28. And we were looking for 25.5. So we know it's sitting in here. Well, what's halfway between 50 and 60? It's just going to be 55. Yeah. So our estimated median in this class, the middle of the data is 55%. So 50% of people estimated would have scored below 55%, and 50% would have scored above that. Okay. So what I want to do, let's just, are there any questions before I move? Let's just do an example of this. Where's my one here? Okay. I want you to do this question for me. In your books, chop, chop, I want you to draw a histogram. I want you to work out the modal interval and estimate the mean, and then try and answer that. And I'm going to give you about 3 to 4 minutes. I want you to have your book out. I want you to have a pen. I want you to physically commit to doing this, because I know from having watched many students, until you're actively applying yourself, your brain is not taking it in. Okay. Whilst you're doing that, however, I'm here. And if you want to turn your mic on, ask a question, go for it. Or you can put it in the chat and I will guide you. But I want you to have a crack at drawing a histogram and answering the questions. Alzan, while they're doing that, is there any, did you manage to see what was going on the website, or did you manage to get any information?
Yes, so currently I have the dashboard open. If there's any learners that says yes,
Okay, let me know.
give thumbs up, I'll let you know. But so far,
Okay.
yeah, all is still well.
Because I just want to try and get into the habit of trying to remember those students, because I think my brain just completely forgets about that. So you feel free to jump in if they're voicing their concern.
I will for sure.
Okay. So how many categories do we have? We have 1, 2, 3, 4, 5, 6. So we're going to need spaces there. And if we look at my chart, let's have a look, frequency. Okay, so the biggest value is 28. Smallest value is 1. So probably going up in 5s would be fine. Let's see. Now, something else that's important, and I actually didn't do this in the first one, is obviously a histogram has a title. All graphs have to have a title because they tell a story. And, you know, what's a movie without a title? And then over here, you would have the name. So this is going to be, or the description of the axis, time in hours. And over here, we would either have frequency. In this case, it's just frequency. So I'm going to put F. Okay. So I'll give you, that's sort of a hint at how you would do it. I'll give you a bit more time. Okay. Oh, I need to zoom in here. Let's make this a bit easier to see. So 10 to 15. Oh, it's still really hard to fit this in. I think I'm just going to pretend that you guys know what I'm trying to draw there. The challenges of teaching digitally. Okay, so 10 to 15 is in line with 8. 15 to 20 is in line with 28. 20 to 25 is in line with 27, so it's just a little bit below that. 25 to 30 is in line with 12. And I've actually got the right answer that I can show you, but I just wanted to show you the process that I would go through to actually draw the histogram. And so let's move that out of the way. So that's what your histogram broadly should be. Easy, so it's going to be just 15, the interval 15 to 20, or this one here. Okay, and then the estimate of the median. Well, to estimate the median, I need to count up how many items there are. So I'm going to use my calculator. I'm going to get 28 plus 8 plus 27 plus 12 plus 4 plus 1, and I get 80. So basically the position of Q2 is just going to be 80 plus 1 divided by 2, or 40 and a half. That's its position. So let's track it down. Essentially, we know that 8 plus 28 is 36. So I'm not quite there yet. But the moment I get to this interval, I know it must be sitting in there. And what is halfway between 20 and 25? It's going to be 22.5. And so that's going to be it. What do these two measures of central tendency tell you about the amount of time the learners devote to watching their favorite sport? Well, it basically, I mean, it's showing you that, you know, the average student is taking between, what was the first one? So this was the median. Sorry, this was the modal category. It was 28 students, so between 15 and 20 hours. And over here, this was the mean. So most, you know, this is the most common. This is the middle of the data. Most students are going to be sort of spending between 15 and 25 hours a week watching their favorite sport, which seems like a lot. Wow. I mean, I can understand maybe 10 hours, but that's essentially what the data is saying. Okay, I know it's quite a long process, this, but I just thought I would give you a good feel for that. How are you? Could you give me an indication, thumbs up or thumbs down? How are you feeling about knowing what a histogram is, drawing a histogram, and interpreting it? Are there any questions before I move on? The goal of this was to show you how we can summarize data into groups and then tell its story with the shape. Okay, one, I see a thumbs down, that's good. I see a thumbs up. Okay. Don't be afraid to let your feelings be known. This is a, okay, so there's sort of a mixture there. Okay. So I'm going to move now. I'm still going to have histograms, but we're going to talk a little bit about the shape of the graph. Now, we don't really have words yet that talk about the shape of the graph. I don't know if you've learned about words that talk about the shape, but this graph, this thing over here, there are different types of shapes we come across. And so we need to learn some vocabulary that helps us describe it. You know, for example, if the graph was looking like this, that's quite different to how the graph or the distribution, if it was looking like that. Or if the distribution, now I'm just drawing pretty shapes here, but these are all different shapes that we need to learn how to describe when we talk about statistics. Does anybody know any words that they can put into the chat that they've heard about at school maybe? Like, how would you describe the shape of a data distribution or a data graph? Or if you've never heard any words to describe this, put a thumbs down. Aha. Okay, I see the thumbs down. That's fantastic. Then I have some fantastic stuff to help you with. Okay. So this is a question from the Watobe app. And it's exactly the thing that I was talking about here. The graphs tell stories, and the stories' characters are on the axes. So let's take a moment to look at this. On the horizontal is distance in kilometers, and this is the interval 0 to 2 kilometers over here. And the next one, the next group is 2 to 4 kilometers, 4 to 6, and so on. On the vertical axis is the number of members, the number of people. So this is saying 8 people ran between 0 and 2 kilometers. Now, what type of graph is this graph? If you had to give it a name, you can shout it out, jump on quickly, or you can put it in the chat. What type of graph is this called? Okay. It is a bar graph, but it's a special type of bar graph called a histogram. Think of history, like going back in time. So a bar graph, it is a bar graph, but traditionally bar charts, they look a bit like this. They have these spaces between. Okay. And often it's because then it's not really numbers, it's categories. Like I said, the one I always think of is comedy shows. Like, what's your favorite comedy show? And you can't really compare them as numbers. They're just separate types of things. Okay, now in statistics, we talk about something called skewed. Now, skewed is a bit of a weird term, but what it's saying is, if you think of a number line, I think we all agree that going in this direction is positive, and going in this direction is negative. Okay, so that's the first thing to start. Now, when we talk about skewness, we often look at what's called the tail of the data, or the place where the data is more spread out. So this graph is actually said to have a tail going in this direction. Can you kind of see it? I suppose we could draw like a monster tail if you really want. I'm not very good at drawing though. So this tail tells us that basically the second half of the data, the tail, is quite spread out compared to the first half of the data, which was quite close together. And we say that the data is positively skewed or skewed to the right because the tail is going in the positive direction. Whereas if the tail was going to the left direction, we would say it's negatively skewed. So I want you to vote. If you talk about the shape of this distribution, do you think it's A, B, or C? Lock in your vote. So this is our new words for the day. It's like histogram, and it's a fancy word, skewness. It sounds a bit like something you do on a bra, but it has a particularly clear meaning in statistics. Okay. All right. So it is going to be C, skewed to the right, because the tail is going to the right. Okay. We'll do another one of these though. Do I have any more here? Oh, wait, I have some here over here. Okay. Now, let's do this one over here. Shape of distributions. Now, this graph is actually not a histogram. It's called a dot plot. We don't really do too much of it in the South African syllabus, but it's basically like, it's almost like a tally chart where the numbers are discrete data. And discrete data, like, you remember earlier lessons I spoke about this, number of fish are either like, you can be a small fish or a big fish, but you can, if you're counting fish, you can only count a set number. Anyway, this also has a shape. And I want you to try and answer, what is the shape of this distribution or this graph? The dot plot showing the number of fish Jamie caught each day on vacation. How would you describe it based on what you've seen or heard today so far? I see those answers coming in. I'll give you a bit more time. Okay, so what you kind of see is the tail on this side and the tail on this side is almost the same. And so indeed, it's B, the distribution is approximately symmetrical. Most, like, if you look here, the median or the most common thing, the mode actually, in fact, when a distribution is symmetrical, often the mean, the mode, and the median are very close together. Now, in this case, you can see it's most common for him to catch 5 fish on a day, but quite a few days he caught 4 fish. He didn't often catch only 2 fish or 8 fish. So those are slightly more unusual. But the story is that the shape of the holiday fishing is symmetrical. And we say it's symmetrical around the mean or the measures of central tendency, which are over here. Okay, you did well there. Well done. Now, going back to this thing called a box and whisker plot. I want you to think, what does this box and whisker plot actually show you? And I'll give you a hint. This is the minimum value. This is Q1, Q2, Q3, and this last dot is max. Do you think the data distribution that this came from, is it symmetrical or is it not symmetrical? And you can vote with A and B. Because remember, this came from a data set that we organized. What do you think? I'll give you a moment to vote. Aha, well done. Yes. So this distribution is not symmetrical because you can see, like, the way to think of it is, this is the middle of the data, the median. 50% of the data fits between 21 and 31. So it's quite spread out, okay? Whereas this 50% over here is all close together. And so the tail is going to be falling off to the left, okay? Now, all they asked in this question was, is it symmetrical? Is it not symmetrical? But you can actually even tell from this that it's going to be skewed to the left or negatively skewed because the tail is going to be going that way. Okay. All right. No, we're doing really well on this. So I think give me a thumbs up if you're feeling good about classifying the shapes of graph. Give me a thumbs down if you're feeling like, oh, I need a bit more. Okay. Awesome. What I want to do, am I going to do frequency charts with you? No, I think I'm going to do one more thing about identifying outliers. Okay, so in the next lesson, we'll carry on with different types of charts that you can do, but I feel like for today, just locking in the histogram is a really, really good thing to do. And so we're going to do more vocabulary around the histogram, which is the first group data chart that we're looking at. Now, another fancy word that we use in statistics is something called an outlier. Now, for example, if you're measuring a whole bunch of things, let's say you're measuring, I don't know, what are we going to measure? Like the weights of fish for a competition, or you're trying to see the size. And so maybe you're measuring and you're catching like a 10 kilogram fish and a 12 kilogram fish and a 15 and an 8. And, you're weighing the fishes. And then someone on the data set that you get as the judge, someone says they caught 100 and no, not even that. Someone says they caught a fish that was 1,200 kilograms. In statistics, it's highly likely that human common sense is the person probably just added an extra 2 zeros by mistake, or there was some human error. And so we don't really want to incorporate a value which is almost falsely in our data set. But figuring out if it's meant to be there or not be there is actually quite a difficult thing. And so we have some criteria that we use to classify values as what we call outliers or not outliers. And so I'm just going to show you what criteria can we use to say, is this value an outlier or is it not an outlier? And I'm going to use this question. So if we look at this question, it says the following. It says, The following histogram summarizes the ages of 25 employees who work for Elon's company. Maybe it's Tesla. Each bucket, that's another word for interval, includes its upper bound. So it's saying, look, this includes the values that were 20 and they were put into this bin. It also gives us, this is a great question because it's including so much. It also gives us what's called the 5-number summary, okay? Then it says, according to the 1.4 times IQR rule for outliers, how many outliers are there in this data set? Okay, so I'm going to do this one with you because it's such a great question. If we look at this histogram, let's just take a moment to see what this means. This is saying there's one person who is between 10 and 15 years of age, which is a bit suspicious because normally people are only allowed to work from when they're a bit older, but I don't know exactly what that is. One person in the category 15 to 20, 4 people in the category 25 to 30, 6 people in the category 30 to 35, and this kind of makes sense, with your working population. And if you are managing a big company, you have to keep a really close look on your age pyramid like this because it affects the decisions of who you're hiring and so on. Anyway, I get distracted. So basically now, how do I answer this question? And what is the IQR times 1.5 rule? Well, first we need to find the IQR. Can you guys tell me what the IQR is using just the 5-number summary down here? Can you put that into the chat for me? So Marcle, I see some answers. Who else? Who else wants to have a go? What's the IQR again? Can someone jump on and just let me hear a voice there? How do I find the IQR? I see some things coming through. Fantastic, 11. The answer is 11. Let's see if I agree. Well, I think I go 42 minus 31, which is 11, because the interquartile range is Q3 minus Q1. Fantastic, guys. Now, the 1.5 times 11 is going to be, let's do this, 16.5. Now, if we want to know whether or not something is an outlier, what we do is we ask ourselves, we go, look, where is Q3? And then we ask ourselves, how much, let me just check this quickly, above the, yeah. So this is how we check for outliers. We ask ourselves what the value of Q3 is. In this case, Q3 is 42. And then what we do is we add the value of 1.5 times the interquartile range. I know this sounds a bit odd, but it has some, I'll explain in a later lesson why it's so useful. So you add on to 42, which is Q3, 16.5. And then you get 42 plus 16.5, I get 58.5. And that is called my upper boundary for an outlier. Now, if I want to get my lower boundary, I take Q1, which is over here. Let's see what Q1 is. It's 31. And I'm going to take away 1.5 times the interquartile range, which is 16.5. So it's going to 31 minus 16.5, and I get 14.5. Okay, so what the criteria says to us is if there is something which is below 14.5, we can classify it as an outlier, or if we find something that is above 58.5, we can classify it as an outlier. But if it's in between that, then we're not going to classify it as an outlier. And so let us have a look at the possible answers here. How many, I want you to try and vote now. From this drawing and using this rule, I hope I haven't cut anything off. Let's see if I cut something off here. I don't want to cut off the right answer. I did cut something off. Which of these do you think, how many high outliers are there in the data set? Well, I'm just going to say, how many outliers are there in the data set? What do you think based on this? It's a bit of a harder question, I know, and we're going to wrap it up after this one. So what are the key values I'm looking for? It's 14.5 and 58.5. Now, where is the value 14.5 and where is the value 58.5 in my data set? Wouldn't 58.5 be, I know it's artificial, but isn't it going to be in that interval there? And where is 14.5? I think 14.5, isn't it going to be about there? So how many people are existing in that area there? That's going to help us, I think. Give you a little bit more time. See some answers coming in. Yeah, well done, guys. So, this one over here, okay, you can debate, is it a 12 or is it a 15? But basically, there's one person in that block and there's one there. And so I would say that there's two values for the outliers. Okay, so when we talk about outliers, often the main thing you have to be able to do is identify them or describe them. And this just gives you a feel for that. And so I'm going to bring the lesson to a close for today. I think we've done quite a lot. And I just want to end with an exit ticket. And actually, before I go to the exit ticket, which I think we can all play together because it's not very long and I really want us to give it a go. Are there any final questions before we do that? And I'll give you a moment to type. Give me a thumbs up or thumbs down, depending on how you're feeling about today's lesson. Like thumbs up if you feel like, I feel like I learned something, or thumbs down if you're like, ish, I'm still feeling a little bit like I need to go back and watch earlier videos, which is obviously an option. Let's see. Okay. I think you guys have done very well to get today, personally. Okay, let's have some fun together, and then I'm going to hand back to Alzan. So you may or may not notice that I love these quizzes, and so I would like us, I'm going to try to play this live again. Don't know if it's going to work out, but I want you to go either on a spare tab or a extra, like, thing that you have. Go to joinmyquiz.com. So joinmyquiz.com. And let me even share my screen so you can see what I'm doing. So stop share. And let's see. So this is what you should be doing. Joinmyquiz.com, and the code is 45425534. And then you click join. And I just want to give you a little bit of time to, you may not finish, but I just want you to start and give it 3 minutes, 3 minutes to try and see if you can play that, because if you learn how to do it, it is there for you to practice in your own time. And then once you've tried it out, tell me what you think in the chat. You don't have to finish it now. I just want you to check you can get in. And then just let us know what you think of it in the chat. And then Alzan, I'm coming back to you. What am I showing the wrong? Let's go back to me. Definitely becoming quite the tab multitasker, I can tell you that. So all I'm wanting to know in the chat is, what is your impression of the quiz tool? The quiz tool. And if you could just put that in the chat, that would be awesome. Or if you're feeling brave, you could just jump on and give us your verbal feedback. That would be cool too. Okay, Ozan, I'm going to hand back to you. If the students give any feedback while you're talking, I'll watch that. But yeah, thanks a lot. I enjoyed today. I think it was, I think we're starting to get a more natural pace. But please do let us know if the pace is too fast or too slow, etc.
Awesome. Did you hear that, guys? If you feel that it's a bit too fast or too slow, please feel free to stop Peter or myself anytime. But yeah, it was awesome to see you guys again today. And like you all know, I'm quickly going to share the work we need to do before our next class, which is on Tuesday.
Yeah.
So something else that we are going to see today is the leaderboard. I hope you guys are excited. It was a bit tight, I must say. Just want to get to the correct one. Okay. Here we go. So, like we said, this is halfway. You guys are halfway through. Give yourselves a hand clap for all the hard work that you've been doing. I really hope that you guys are learning so much on this platform, but also taking it out into your own homework and the test that's coming for you guys. So before we go on to the revision work, are you guys ready for the leaderboard? Let me see some emojis. I'm sure you guys are wondering if your names are on here.
I feel like there should be an emoji for like wobbly hands, thing. Hold up. Yeah.
So here we go. It's very tight, like you can see. We've got in first place a tie of 3, Sesetu Jason and Tokozani. So well done for completing 6 lessons. In second place, we've got a tie with Ontatile, Joy, Solofelo, and Marilyn. 5 lessons done. And then in third place, we've got Sabelo. So well done, guys. Can you give them a bit of a dance? This dance is for you guys. So well done. And then it's not too late. There's still next week. Thursday we'll do the leaderboard again. So if you want your name to be on here, go and work hard, and you will get rewarded. Okay, and then
I will
next
also bring up quiz stuff out.
Awesome. Yes, yeah. Next time we'll show the quiz as well. And then for the revision work, you guys know where to go on. You go onto your Watobe app in statistics, and there you will find, when you scroll down, not this one. Sorry. This is the one that we're looking for.
Skewness, yeah.
Skewness, okay. So this is your work for Tuesday, before Tuesday. And remember to do the quiz as well that Peter showed you if you haven't already. But that's all from our side. Thanks, guys, again for being here. You still need more practice.
Thanks, everyone. Okay. I hope you have a pleasant evening. And I'm sure you need to go for a run or have a shower or something now, because that was quite a lot of math.
Well done, guys. Take care.
Thanks, Ozan.
Thanks,
See ya.
Peter. Bye.
Ciao.